Hello, dear students. Today we will see the unit number 4, and unit number 4 is digital CMOS circuits. The first slide shows the syllabus which is in the unit number 4. It contains NMOS, PMOS. The combination of NMOS and PMOS is a CMOS. Then MOSFET parasitic capacitances, then channel length modulation, hot electron effect, velocity saturation. All these are the second order effect, or you may say nonlinear characteristics of MOS devices. The next one is a CMOS inverter, device sizing, CMOS combinational logic design, power dissipation, power delay product, body effect. Body effect is also included in that hot electron effect, or you may say a nonlinear effect over there, a characteristic of MOS device. Then rise and fall times, latch-off effect, and transmission gate. Transmission gate we will see at the time of CMOS combinational logic design. First, what actually the CMOS transistor is? This is the structure of CMOS transistor. If you see that, you can see the p-type substrate. On this p-type substrate, two heavily doped n regions are over there. Out of these two, anyone can be a source or drain. That's why it is a source/drain regions. The one which you will connect to VDD will become drain, and the one which you will connect to the ground will become source. Below the polysilicon gate, there is a very thin layer of gate oxide is over there, and above the gate oxide layer, there is a polysilicon material which is forming a gate. Now you can see the different types of symbols which are being used for MOS transistor. This is for NMOS enhancement transistor. This is for NMOS depletion. This is a PMOS enhancement, and this is a with bulk terminal. Bulk terminal is also called as a substrate terminal. Now here these two symbols which are most common, and we are also using these two symbols in our teaching. This is a current voltage or IV characteristic of a MOS devices. You can see that on x-axis the drain to source voltage is being applied and the drain current is being measured. This is being done for different gate to source voltages. The gate to source voltage is 1 volt, then 1.5, 2 volt, and 2.5. You can see that initially the current is 0, later on it goes on increasing, and after a certain value of the VGS DS is equal to VGS minus VT, till that the current is increasing. After that the current is remain constant, and you can say that the transistor is in saturation. Whereas the earlier region, you may call it as a non-saturation, or you may call it as a linear region. The same working can be explained with the help of these figures also. In this figure, only the gate voltage is being applied. When you are not applying the gate voltage, there is no channel is present below the SiO2 layer, or you may say the silicon dioxide layer. Okay, when you apply a gate voltage greater than 0 but less than the threshold voltage of MOS transistor, because of positive voltage applied to the gate, the positive ions which are present in the P substrate are being repelled, and there will be a depletion layer below the gate. When the gate voltage is more than the threshold voltage, the depletion layer is further pushed inside the substrate, and from the substrate, whichever the negative ions or electrons which are there, which are being attracted towards the you can say attracted towards the gate, and they are being accumulated below the SiO2 layer, and this will form a channel. Next part we will see in the next lecture.